Yo, 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 what's up, everybody? Welcome back. Today we are working on building a constellation that is representing our code base. A nice little visualization, a map of the stars, to try to get a feel at a glance for how our code base is connected. So the idea is um, let say we've asked a language server the like way where when I open my editor, if I go into like a file and I say like who references this project root thing, that asks a language server to give me the references. We have basically asked the language server ahead of time to give us all references for all structures, unions, enums, and functions that we have in our code base, right? So we've built up this database to say like in this file, this function log error is called by main a bunch of times, app widget once, and then in these like GLFW callbacks, right? We have that the UI action in some file is referenced by all of these places, right? And the idea is we want to create some visualization that basically says UI action, this guy is used all over the place, right? It says he's used by main a couple times, he's used by app widget a lot of times, right? He's used by all of these other things, blah, 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 make object list, whatever. The idea is that we want to try to build a map of like where these things are connected, right? So like we see that a lot of people are referenced by main, right? Main's kind of in between like GLFW, he's in between args, he's in between UI action, he's in between make object list, create object list, right? So we're trying to hoping to see that like main is in the middle of some graph or something, and he connects to all of these things, and we just want to like lay that shit out automatically, see what it looks like, and hopefully we can gain some sort of intuition about like how a code base looks. I guess the long term goal here is to provide at a glance info for viewers as they come in, for like the context for what we're working on, right? So we'll probably we'll start trying to weight this graph towards like where we're spending more time. But to do that, we have to start by visualizing something, anything at all, right? So today we are going to try to render something, and then once we have something, we can iterate. So plan of action is just take this data that we have, open a OpenGL window, render a node in this graph, and then try to figure out how to like render this stuff. So I'm kind of assuming that like things that have lots of connections will end up closer together, and I don't really know how to do that. My current idea is to try to lay stuff out, just kind of like put nodes around, right? Nodes that connect to each other will pull each other towards each other, right? So I'm like, this guy's like, I'm referenced by him and him. If he references me like 10 times and he references me like 5 times, I'm gonna try to go like mostly towards him, but a little bit towards him. Everybody who references me will pull me a little bit, and I'm hoping that if we just like iterate that a few times, well, if we were to just only pull, everybody would end up in one singular point in the center. Everyone would eventually pull themselves into like one singular point. So we need some sort of like counteraction force to that. Like try to space yourselves out, but also try to pull yourself together towards things that you care about, right? I'm hoping that we can come up with some form of algorithm that like we can iterate that a few times and end up with like some sort of stable graph. So we'll see how that goes. And if it looks like shit, we'll have to do something else. But we'll figure that out as we go, because I'm sure that how it's shit will inform what the next stage is. So let's jump in. Let's try to open an OpenGL window, render anything, and then once we have that, we can start rendering nodes. Once we have that, we can start spacing them out. Okay, so I think I just want to copy paste some of the OpenGL initialization code that we have in our other project here. I think that we can just say we will use GLFW, OpenGL window initialization library, and let's just see if we can copy paste him, and if he works, he works, Can I paste with what I just did there, or did I? Yeah, I can't. Let's go to here, source main, GLFW. Let's just copy all this stuff again. Yoinkies. We could do the whole OpenGL hello world again, but I don't really feel like it. We've done that enough times that we should just be able to copy paste. Okay. GLFW bindings are going to come from I guess we can do this directly. Include the GLW header, and then presumably, I think that we're not going to do any keyboard handling right now. Cursor handling we probably will have to do, but I think that we probably don't have this, like, we're probably missing a struct definition that's required for this. So let's kind of ignore this for now as well. We'll just ignore everything but trying to get the window open. So we just won't set these callbacks that don't exist anymore. Fuck keys, fuck cursor, fuck, yeah, fuck everything. Fuck everything. We don't need any of this shit. I guess we want the error callback, wherever that is. Oh, that's already used up there, so we're good. We are good. And then I think this log error thing isn't even used anymore either. Perfect. So we have some window, we initialize the window, we set some hints for some OpenGL stuff that we want, and then we say we want to swap every frame, or one per every vsync, every refresh of your monitor we want to swap. And sure, seems reasonable. Seems reasonable. We have a way to get the window size, we have a way to swap buffers, chill. So we should be able to just be like in our main function here. I think I want this in a different file, actually. I think I want this in a new thing. We'll kind of consider database generation and visualization separate for now. That will be easier. Are you on mainland? Yeah, we are. So let's just do this. Okay. So here, and then we had the GLFW imports. We'll kind of put this over here as well. Okay. So function main. Let's do return error. Just make sure that we're, we're up and running, and we'll add this to our build script. So we'll be like, let's add viz from source viz. We spelled it with an S here, so I guess we'll spell it with an S here. We do want to install this artifact. So we will say install this thing, and then surely we're going to have to link libc and GLFW. So we'll be like link system library GLFW through GLFW question mark, maybe? We'll see. We will see. He's pissed because in Viz we need to say public function main. He can't run it if it's not public. He needs to know the function needs to exist, Looks like that's fine. So if we run this now, he goes, uh-oh, which is great, which means that now I can start saying, like, can we make a window, please? I guess we do it like this. I think this is how he, as in me, wants to be initialized. And his init functions are width and height. So let's just do like 800 by 600 for now. And we have to build this, I guess. We need to try. So zig build and this. Let's see how that works. Okay, so we're back. We initialized successfully. I think that we need to check what is our main loop supposed to look like here. We probably do a GLW swap buffers while we're not closed. GLW swap buffers. Let's just see what that does. That hopefully gives us a window. Nice. He's got the name of our image editor hard-coded in here, which is kind of funny. We'll call this viz. And we got a window. We got a window. Okay, now let's try to do anything OpenGL in here. So can we do like C include GL at H and just do a quick little like GL clear with oh, I guess we'll do it like this. Zig people don't like when you do this because it calls like the LLVM parser multiple times and stuff, but fuck it, I don't care right now. I don't care. Eventually this will go somewhere else anyways, so. We do need to link system library of GL, I think is what it's called here, and then that should work. He's pissed about something. Oh, we do need to finish this. I think it's GL color buffer bit. Why is he mad still? He's mad because C import failed. GL.h not found. That's annoying. Let's make sure that we have it in our environment. We do. It's libgl. What do we do in our other project? We just do link system library GL. Seems pretty reasonable. I don't know why he's angry. Is it that the header is wrong? Hold on. Image editor source render. Other way. I see. It's GL. Of course. It's not GLGL. It's GLGL. You know. Just case swap everything in here. Okay. Okay. So let's set the clear color to like red, just to make sure everything is great. Boom. Okay. OpenGL up and running. Now, if we want to do anything sane, we want to render a circle, right? How do you render a circle in OpenGL world? Well, there's not really like a circle primitive, but what you can do is you can render a square, and you can write a custom program that says for every pixel in this square, can we check for every pixel in this square, are we within the circle that is centered in the square, right? That's a thing you could do, right? Now, the problem is, to do this, you need to set up a render pipeline that takes, you can't render a square either, right? You can render two triangles that are attached to each other, which means that you need to set up like a vertex buffer that shows where these like 4 points are, and then you have to also like make some UV coordinates that can be passed along to the fragment shader. This calls like a vertex shader, which is a program that will manipulate these things. He'll pass those things on to like a fragment shader, which is where the code to run this rules are. All of that, pain in the ass. All that OpenGL setup, pain in the ass. And I was thinking, eventually in our code, in our thing, we're eventually going to want to render like, we're going to want to render words. We're going to want to like app.zig here or something, right? That's like a thing that we're going to want to do. And so if we're going to want to render text, we've already done this whole saga, right? We've written like a TTF parser that generates, that does like text, and then we've like to do text layout. That text layout will generate buffers that are like rendered planes that sample from some like glyph atlas, right? And these get like passed into OpenGL land. We've already done all this work, so we're going to pull. It's almost certain that we're going to pull in all of that work that we've done from our image editor. So we might as well just start there, because as part of this work, we have nice abstractions around basically running a fragment shader for a plane. That's like a thing that we have in there. So I think that it makes sense for us to just kind of like yoink all of the stuff that we use for that in our image editor. Usually we would like start from scratch, but fuck it. We don't have to yoink in the text stuff yet, because we're not going to do that right this second, but we will yoink in the math stuff and the rendering stuff. So can we look at how we build that stuff in our image editor? We have math and render like this. Pretty straightforward. And then we should be able to just use these things in our executable. So we should be able to be like, create me a module. We'll be like viz add import. Nope. Yeah. Root module add import. There we go. We probably will want math stuff, almost certainly, and we also want render stuff. Okay, so that means we should be able to go into our vizzig and say const render is our rendering library. And we should be able to be like render dot plain render program, initialize this thing. We need some allocator. So I guess we will do this. We will say we have some general purpose allocator, comes from the standard library. general purpose allocator with I don't give a fuck arguments. We will check for leaks on exit. And then we get our allocator, which means we can pass it into this thing, which will render a plane somewhere. We need a vertex shader and a fragment shader. You started from scratch a year ago. This still counts. Hell yeah, dude. Can we copy? I think we have a default vertex shader in here somewhere. Yep. Do we have a fragment shader? What's in here? This thing. We'll make our own. We'll just say, let's render a we'll say that our fragment shader takes in nothing, I guess, and we'll just output a color. We're not going to do image sampling. So we'll just say, like, give me a 1.0, 1.0, 1.0 thing. We'll draw me a white square for now. Let's just see if we can render a white square. Index type is null, probably. Sometimes I use geometry shader to generate the quad. If you never read the input primitive, you don't need them. It doesn't crash for me, at least. To set up any vertex data, it all just tie and call GL draw, GL.1. It's a fun trick, but it's stupid. Don't do it. I've also heard that like those geometry shaders are like, I've heard people don't like them. Like I've heard they're like slow and shit. I don't really know why, but I have heard that. Okay, so here's some program now that we can run. So can we go here and just go like program.render. And we need to render with some buffer. So I think we do like make default buffer. This will give us a square. This will give us a square that fills the screen, I think, is our default. And so if we do this with our buff, and we just say like, I don't give a fuck, I don't give a fuck for now, and we need a transform to say like, okay, so we're gonna give you like a square that fills the world. What if we want to not fill the world? Well, you can like apply some transformation to that thing. And for now, we will just say, could you fill the world? Or maybe we'll scale by 0.5 in each dimension. Yeah, that seems reasonable. So we're hoping to see a white circle that's kind of like centered in the screen. When's the Vulkan from Scratch series going to start? I don't know if I ever need it, is the thing. I feel like the like gain that you get from Vulkan, it's black, it's close. It's because we used the wrong shader. Yeah, the gain you get from Vulkan, I feel like, is that like you get more control. But like, I don't really need more control, you know? I feel like I've got too much control as it is. Like, I don't know what the fuck is going on. Okay, so we have our quad. We can draw a little white rectangle here. We need to turn that thing into a circle. So I think that we can just say in here, what, like, if the UV coordinates here are like, the left side is, it goes 0 to 1 in each dimension. So you have like, I think it's 0, 0, 1, 1 here. We can double check that. If we just take the uv.x and uv.y and put them here. Please don't give Mick more control. Yeah, exactly. Whoa, that's not what I expected at all. Oh, because the other side's, I'm used to doing this with 0 on the green side. There we go. So black, red, green, yellow, which means that this is 0, 0, this is x1, this is y1, this is 1, 1. Okay. That is how this works. So we should just be able to be like, if we want to draw a circle, we just want to go like if, I think we take like uv and minus 0.5, right? That will make it so that the center of the quad is at position 0. So we'll say vec2 center is equal to this. And then we just want to do like center dot, this formula for a circle is what? X squared plus y squared is equal to r squared, right? So we have to have some radius in, I guess, 0.5 radius would fill the whole quad. So I think that's reasonable. We have float r2 is equal to 0.5 times 0.5. right? Now we just have to be like uv.x times uv.x plus uv.y times uv.y. If that is less than r squared, then we render something. I guess we'll say that if it's greater than we discard. That seems reasonable to me. So we say here, discard. And then otherwise we set it, we'll still use the like whatever color we were using before. Not good. Not good. Because I'm supposed to be using center here, not UV. There we go. That's a circle. Now we need to make sure that our quad stays like square in screen space, or else it will look stretched like that. And instead of actually fixing that, we'll just make our window 800 by 800. It's the easy fix. Now it's a circle. let's stop clearing the background as red because that's ugly as fuck. Okay, and then let's set the color of this thing to just be like white. Okay, so we can render a circle now. Let's go. Let's think about if we want to be able to render it at any position and scale. How would we do that? I think the intention when Vulkan was released that no one would use it as is, and there would be pop-up like dozens of SDLGP-like things. Yeah, that's kind of what I assumed as well. It's kind of like a game engine thing, you know, is my understanding. Like, it's expected to be used heavily by game engines, but then, like, people are actually just supposed to use engines like normal people. I guess let's load. Let's position the nodes somewhere. Let's render many positioned nodes. So say we want to render like 4 of these little circles and we want them to be kind of small. How do we do that? How do we do that? Positions. So let's define a coordinate space that we will work in. We can just work in OpenGL coordinate space. I think that's probably fine. So we'll define like bottom left is -1, -1, top right is 1, 1. Then all we have to do is like move these things so that they fit in that space. So say we want to make like a grid. Let's make a grid. Yeah. So we'll go like for make node buffer, I think is the way we want to do this. So we'll say given a set of positions, could you give me a buffer that represents those things? I think that's reasonable. So I think that the APIs we have on this buffer thing allow us to update the buffer with buffer points. Hell yeah, dude. So all we have to do is define these. We just have to define an array of buffer points, which is easy. We just go I don't know. We need some allocator here probably. Allocator. We could do this a little better, but I don't give a shit for now. Allocator, std_mem allocator. We could make it so that we could like just feed in these things as is to the buffer API, but I think we'll just make a buffer of their buffer points. That's fine. So we'll say these are buff points is going to be a std array list of render plain render program buffer point. Okay. Defer buff points unit, and then all we have to do is iterate over our positions. And for each position of our circle, we need to create a quad that represents those things. Wait, you just edit a comment? These are multi-line strings. In Zig, double backslash is multi-line string, double forward slash is a comment. So this is a like code that's being passed into the OpenGL world. So like the how do I say this? In OpenGL, you are taking this like high level language GLSL. I know it doesn't look very high level, but it's pretty fucking high level. And you're saying, okay, I have like a graphics card in my computer. Could you like convert this shader into like something that my GPU can run? So instead of like normal code where you would like compile your source code and ship the binary around, with OpenGL, you have to ship the source code around because every GPU will have different, like a different compiled representation. So this ends up being like a string in your program, which is kind of funny. Kind of funny. Can we do like buffer point is equal to this? I want to do a little type alias so I don't have to type this like fucking like 75 character string over and over again. Okay, so for each of these things, we need to generate a quad that represents the bounds of our circle. So I guess we're also going to want like a size. Circle size. Circle radius. And all we have to do is we take the position of our circle and we say that the top left is the position plus circle radius. This is going to be like, hold on. What are the types that we expect here? Literally just F32s. Okay. So go like this. The top left is positive in Y, negative in X. And the UV position of the top left, I guess, will just be we'll keep it in the same world like this. Bottom left is 0, 0. So that's minus, minus, 0, 0. Top right is 1, 1. So this is plus, plus, 1, 1. And the bottom right is x1, y0. So it's like this. And then we put these things in the buffer. They need to go in the right order so that when we draw a triangle strip, it works out. So if you want to draw these two triangles, oh no, it doesn't. The order doesn't matter here. I forgot. We actually do GL triangles now. So we need to push 6 vertices to make 2 triangles. We need 0, 1, 2, and 1, 2, 3. So top left, top right, bottom left. Okay. So we just push into our buff points, append slice of it's top left, top right, bottom left, and bottom left. We need to keep the winding order the same. So bottom left, top right, bottom right. I think this is the order that we want. Pretty sure. And then I think we just say like program. We need to pass a, I guess we'll say update node buffer. And then we'll take in like the buff here. Like this. And then I think we can just like say swap my shit out, please. Update buffer with these points. And then I assume that this actually does a reallocation here. Yeah, it does. Sick. Sick. So then we can be like, give me these buff points. And I think that's it. So now if we want to render these things at some location, we should be able to be like update node buffer, allocator, buff. Let's put, what was the 4th argument? Circle radius. So let's make our circle radius like 0.05 or something, make it kind of small. And let's put them at a few positions. So we'll say put one at negative 0.5, negative 0.5, put one at 0.5. Let's just kind of make a square of them. How about that? So like this. So we should have 4 points is what we're hoping for. Each of these is actually supposed to be a vec2, so we kind of go like this, and then we go like this. Okay, he's mad because we need to do pause x and y here. So it's pause 0, pause 1, pause 0, pause 1, pause 0, pause 1, and 0, 1. Okay. Fuck. Area unit is ignored, so we need to write try here, which means that this thing is failable. Which means that the caller of this thing needs to write try here. Fuck. I guess that means that this thing needs to take this thing in by pointer, which means here this thing needs to be a variable, and this thing needs to write ampersand. Nice. Close. Looks like we're only drawing the bottom half of each of these things, which is a little confusing. Did I get the triangle wrong? Top left. I don't see how. Bottom left, top right. Bottom right, top right. Yeah. Weird. Weird. Okay, let's just see what happens if I just put more of these things. I'm assuming nothing changes. Okay, and then if we do something stupid like this, nothing changes. Yeah, okay. Why? Have I got some of the coordinates wrong then? Top left seems right. Bottom left, double minus. Top right, double plus. Bottom right, plus minus. Wait, I have bottom right and top left look the same here. This is supposed to be minus plus. Much better. There's our little 4 circles, baby. Okay, yeah, seems reasonable. 4 circles. Boom, 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 boom. So now we can kind of position these things however we want on the screen. All we have to do is define like centers for the points, which means that we can start just like trying to fucking slam some starts like trying to slam some nodes on the screen. So I guess we need to load our node database. So we have some database of connections that we've pre-generated. So we should be able to go like, yo, I have a database. Now, what we did was we just kind of like spit out that database as a JSON file. So we should be able to be like, my args are like this. We'll pass in the location of the thing on the command line. So here will be like the first process args free of args. We'll be like, okay, so this thing is passed in. Let's open it. So this thing at args1 with I don't give a fuck arguments. So well, this is like the DB. This is like the saved DB file is equal to this. We'll see this in a kind of braced area, so I can go do like a defer saved dbf close here. Let's parse from token source, which means that we need to create a JSON reader out of this thing. So I think it's like this. So this is a JSON reader is this, which needs to be de-initted, I believe. Something like this. He's not happy with that though. I could have sworn that this reader has some allocations going on. Yeah, he does have DNet. I don't know why he, I don't know why he doesn't like this. That should work. Confusing. We'll see. We'll see later if it doesn't compile. Then we pass in the JSON reader here, and we have some options here that we can pass in. So we need an allocator. We need options. I don't give a fuck. And this should give us something. So we'll say like the db is equal to this. I think like something like this. DB parsed, I guess, is probably the right word for this, because this thing comes out as this like JSON parsed value shit. And we probably have to like defer db parse dnit like this. Okay. But other than that, we should be ready to fucking go. So does that compile? If it doesn't, why not? You know? Args free needs an allocator. True. True. JSON reader's pissed because actually, oh, because this isn't tryable. I see. I see. Here he needs to say what the type is. So can we just say we want to load a DB from this JSON blob? And does that succeed? No, because we didn't pass in the file. But if we do pass in the file, then he's pissed because there are unexpected tokens. That's not good. That's not good at all. Let's make sure that we generated this with the same code. It could be that we just we made some updates to this thing and we might not have let them run. So give him a sec to find references for all files in this file that we are monitoring, this main file for our image editor. He's just going to go through, build a bunch of references. He's asking the LSP over and over, hey, could you find references for this? How about 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 this? And then he eventually should write them down. So if we do ls-l here, we should see db.json edited right now, which is good. And if we run our vis again, he doesn't like that. So what did we save here? That's a question that we should ask ourselves. We took our db nodes items. I see. So that's why. It's because we are actually trying to get a slice of node here. That is why we were expecting this. Let's see if that works. There we go. Okay. We have our list of nodes now. So what is in here? What is in here? A slice of nodes is, he has a list of who references him, his name, and maybe like his parent in the hierarchy. So really, the thing that we're going to care most about here is the referenced by. The idea is we're going to go for each node, we're going to like put them out in the world somewhere, and then have them pull each other towards themselves, like pull their friends to each other. Yeah, so let's start by maybe like, let's just start by putting every node in our graph as a point randomly scattered. And then we will start stepping this algorithm and trying to see if, how do I say this? We're going to step the algorithm and pull things towards each other and see if they create clusters in some form. Obviously, eventually, they're all going to kind of like collapse into one point. But if we move slow enough, then maybe that will be okay. So can we do something like, I guess we want to, in our while loop, we need to like make a list of positions. Let's just start there. We'll say we want some sort of like graph, right? And we want to store, I guess, nodes as this thing, right? And maybe we store their positions separately. Like this. Okay, that seems reasonable. When we initialize this thing, I guess we're going to take in an allocator. That seems reasonable. As well as the nodes. Okay, and we'll say, let's allocate a new thing that's the same length for our positions. So I think it's just like this. Okay. Sure. We need to set some sort of initial positions for everything. So let's do that. We'll say for each node in our graph, is there like stood random? There's like a default RNG here, initialized with some seed. I don't give a fuck. And then I think you need like RNG random like this. And then you need to do like rand dot float. I think float gives you a linear 0 to 1 distribution. Okay. So we say for positions, give me 2 floats. Okay. But these are in the range 0 to 1, and we want them to be in the range -1 to 1, so we multiply them by 2 and subtract 1. Okay, so something like this. Then we say pause is equal to xy. Boom. Seems reasonable. Seems reasonable. So now, once we have our graph, can we do like graph is graph init with our db parse value? Boom. Defer graph dinit. Doesn't exist yet, but surely it will need to, because we are going to need to free our positions. So let's do that. Okay. So we're gonna go like self positions alloc free, I guess, like this. Boom, 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 which means we need self here, and like this. Boom. Okay. He actually still doesn't like this because this has to be tried. Nice. And then we should be able to, instead of doing whatever the fuck we did here, can we just update the node buffer with graph nodes? And then I think actually on update buffer, yeah, it's actually fine. It's actually totally fine. Totally fine. Graph init requires 2 arguments. One of them is probably the allocator. Almost certainly. Okay. And then a rand float is mad because... Is this supposed to take an argument? F32. Close. We need to do dereference this thing. So it's a pointer. And positions is actually what we want here. Fuck me. Expected this, found that, because this is already a list, so we don't need to relist that shit. Okay. And we should see initial positions. Let's go. Probably too big, to be honest. Can we half their radius? Am I stupid? I am. I did 1/50th instead of half. That feels pretty good. Sure. And I think fun, like, even though it's random, they should get the same positions every time because we're using a seeded PRNG with the same seed every time, which is fine. And now we can start doing things like, let's step this thing. So here's what I'm thinking. We rip the whole node graph. We say, for self nodes, we know that these things are going to be referenced by someone else, right? So we have like node referenced by ref. This reference is just a node ID, so we can like say we have like positions. Other pause is it here, right? And I think all we have to do is maybe we kind of construct some sort of like movement. Okay. So like maybe something like this. And all we have to do is say like movement is nudged towards this other thing. I suspect that we want like a non-linear function here, right? If we're really far, we want to be pulled by some amount less than the distance of that thing. So if I'm like here and here, right? Let's say that this is like really, really far away. We still probably only want to move like this much, right? But if it's like really close already, we probably don't want to move at all, right? So some sort of like this type of function makes sense probably with some like 1.0 is equal to 1.0. right? Something like this. Probably like exponential function. What is that thing called? Like, what's this? This is at 0 distance, we get 1. And at big number, we get big number. Which means that we can just subtract 1 from the distance? No. Big number, big number. Big number, big number. Small number, 1. So we want to do like minimum pull. So we want to do like just hand wavy. Oh yes, big number, yeah. So we want like the biggest number to be the distance between them. Which means that this isn't really what we want. Right? We want something that like approaches 1. So we almost want like if they're really close, no pull. It's almost we want something like this, right? So like when things are close by, this is shaders, right? Smooth step is always the answer. This is for we're doing this on CPU, but maybe smooth step is kind of sane. Yeah, I want something that approaches 1. Approaches 1. So like just okay, don't judge me. What is a function that gives 1 at x equals inf and 0 at x equals 0? Really? This is not okay. Dude. Continuous function accelerates quickly at first, slow later. 1 over 1 plus e to the negative x. That actually seems like something I've seen before. Was that 1 over 1 plus e to the power of negative x? But he's ranging negative infinity to infinity. 1 over x? That sounds pretty reasonable too, huh? But like backwards? Plus 1. This is what I want either. I want something that's like starts at like goes through 0 as well. I want something that goes through 0. What was this again? 1 over 1 plus e to the negative x. Is it just 1? Is it just not 1 plus? Oh, this is stupid. This we already got here. Is there something where at 0 it's 0? Jesus Christ. All of these are gross. All of these are gross. I used to have said 1 over x squared. What does that look like? I guess we can just do 1 minus something, right? We can do like 1 minus 1 over x. Because 1 plus 1 over x? Negative 1 plus 1 over x? Oopsies. Okay, negative 1 over x has like the shape I want. Now I just want this thing to come like up by 1. Sure. But then the problem is that we get to like negative infinity. But we can also pull it to the left by a little bit. There we go. That's what we're looking for, baby. Let's do that. Which is probably the same as what RC Arston just wrote, x over 1 plus x. I think that kind of like lines up the same. Yeah, nice. We just wrote it different ways. Sure. Seems reasonable to me. Seems reasonable to me. So this is going to be and then I'm multiplying this by distance, which is kind of funny. I don't know, man. Whatever. Calc pull. So we're gonna give like distance. Is gonna give like a new. We're probably gonna give some sort of like offset as a vec2, right? So we are some x and y distance away, and we are gonna give some movement as a something related to that. And we said x over 1 plus x, right? And we're gonna do this in like both dimensions, or yeah, I guess. Offs. So here we want like, I guess like the magnitude of this thing. All right, we're looking for like how far it is. No, we want the distance. Yeah. So here we say that the pole is the magnitude is the distance times distance over 1 plus distance. So if we're like really fucking far away, we'll just go snap right to the place. And then we just multiply that by the direction. So direction is smath normalize this thing. The distance is that much. And so we say like dir times splat full magnitude. Seems kind of reasonable. I feel like we've done something silly here. This feels really dumb, but maybe it's fine. Maybe it is fine. So let's do movement plus equals the calc pull of us. So we have like pause is self positions at node index. Okay. Okay. So we're calculating the pull of other pause minus us. Hello. Okay, there we go. Yep. And then we just apply the movement. It's almost like we want to apply all the movements at the end. I feel like we don't want to like step some of the nodes first, then the other ones after. So I almost want to do something like this, where we do like alloc, some vec2s. A few years ago, I was crowned for a project visualizing electron clouds in Unity. There's a bunch of literature on how to handle atom cores, like how hard they repel electrons. Spent several nights in the lab googling soft core before I realized maybe don't do that. Yeah, I've been there. Googling things at work that are like you think are totally innocent and are like very much not totally innocent. Okay. So for each node, we want to calculate its movement. We want to memset these movements as 0. Then we say movement here, like this. We dereference the movement that we got. And then we should be able to go like 4 nodes, movements. We have like node and the movement. No, we want positions. We don't. We actually can just like kind of slap all these things together. Actually, like this. Yeah, yeah. And then here we go like for positions and movement. We just apply that movement. Yeah, yeah, yeah. So then for each step, we go like graph.step, which is obviously stupid. Fix me, use a real time interval. But let's just kind of see what happens if we do that. Movements is mad because we didn't write try here, which means that here we have to make this failable, which means that this thing needs to write try here. Okay. Movements deinit is mad because it should be alloc free. Not bad. Not bad. And this can be const. That's true because it's a pointer. Okay. Now, it could be that these are like discontinuous, right? We're seeing that like we definitely see some things pulling each other, like this and this, but then a lot of stuff just isn't fucking moving. So can we actually make it so that things that aren't referenced by anything aren't in the graph? It's probably the fucking way, right? So here we want to filter these things. Fuck. Let's think. First of all, let's times 0.25 or something. Let's make it move slower just to see if that changes anything. Color would help. Yep, you're right. Yeah, I suspect that there are just things that have no references. So how do we do that? I guess we will still calculate polls for them. No, we will just say if node referenced by items len is equal to 0, we continue. Yes. Then we also have to remove them from the position list. So can we go like like relevant positions? That'll be good enough for now, yeah. We can do some extra allocations. I don't give a shit right now. Normally I would try to avoid them, but I don't give a fuck. I just want to see something. So we'll go like for self, node self positions, node position, if self, if node referenced by len, items len is greater than 0, we do like output dot append position, sure, which means that we need some sort of output of vec2s probably. Defer thing dot var output here, and then at the end we go return output to own slice, which is an extra allocation again, but again, I really do not give a shit right now. So then we go like in each frame, we say like const relevant positions is graph relevant positions. We say defer alloc free relevant positions. And here we pass in our allocator. Okay. Okay. Fuck. Try output append, error out of memory. This thing needs to write try. This thing needs to be failable. Interesting. What did I do wrong? Am I using the relevant positions? I'm not. That would do it. Okay, so now what's confusing to me is I feel like something should be connecting these, right? So it would be interesting to see what like the two sides of this thing are. So can we like look at maybe we just log the positions of everything. Just to get a feel for if there's like if it's bisecting the graph in some way. So here can we go like for self nodes self positions pause node pause. Can we just say like std debug print this thing has position this. And let's just look at the node name and the pause. Let's just see what it looks like. Too few arguments. True. True, 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 true. Okay, so we kind of have like app widget on the left side, and we have other app widget on the right side. That's interesting, right? So here we can see like app widget is referenced, probably the left side is like main. Main has position left side. And then what's happening here is that all of the like children of app widget are not like anchored to him in any way, right? So we need to pull towards our parent as well. And we probably want to pull towards our parent harder. Kind of hand wavy. So that means that here do we want to pull towards our parent or do we want to pull our parent towards our children, right? If our children are referenced all over the place, we kind of want like bi-directional pull, I think. Maybe we want to allow like something over here to pull all of the children of this guy, which will pull him with him. Right? That kind of makes sense to me. So I wonder what the right play here is. I think that you want to keep all, we want to like keep all children nearby. Have you looked at force directed graphs for layouting? I think that's kind of what we're making. I kind of just made this up though, and then I Googled it after, and I was like, oh, somebody else said the words force directed, and I was like, okay, that means that I'm not doing something that's like totally insane. So I think we want to keep all of our children nearby, which means like some really aggressive pull. Then we also want to pull parent by some like by addition of all children pulls, scaled down probably over num children maybe. That seems kind of reasonable. Yeah, so maybe we take the movements that we calculated by just like from the references, right? And we just say for self nodes movements positions probably. We probably want all of these things. We don't know how many children we have right now. That's like not a thing we know. We have child to parent mapping. We don't have parent to child mapping. Which might be a little bit of a pain. Might be a little bit of a pain. So probably we want to construct that relationship. Mm. Right, so we'll just do this here for now. Eventually this should live in the database. But for now, this will work. So let's uh just pretend for now like we've done this already. Created this like this mapping. And let's say that like if we had this mapping, how would we use it? We would say like maybe we only need num children actually. We actually might only need the number of children. In fact, I think that's very likely. So maybe this becomes num children for now. Uh-huh. And what we do is we say we have some parent. We want to hold on. Parent num siblings. How many siblings do I have? It's my children, num children at if we don't have a parent. That is like a very real possibility. So we'll say parent ID is equal to node parent or else continue. We don't care. If we don't have a parent, we don't have anything to do here. But if we do, let's see how many siblings we have, okay? And we will like kind of like pull our parent by that much as well. So we'll say like I think this is like this, yeah. So we'll say like our movements at parent ID value plus equals our movement. Yeah, is our movement over our number of siblings. I think that seems reasonable. So you're like, you fucking have to move with us, bitch. And then we also calculate a pull. So this is like pull parent with us a bit. And then we'll say keep us in range of parent. We want to stay close by, which means that we basically want to adjust our movement such that he's pulled back towards his parent. I don't know. We're just kind of making shit up, but it seems kind of reasonable, right? So the parent position is positions at parent ID. Then we have the parent pause minus us, and we kind of pull ourselves back that way. I don't fucking know, man. Okay, so now we have to construct our children. So children for nodes is a array of U32s that have this many elements, one per node. Okay. And when we construct this thing, we just say like mem set this thing to 0. Every node starts with 0 children, and we just rip the graph. Yeah, we just say like if node parent we say children for nodes at ID plus equals 1. Easy. Easy. Let's see what happens. Fuck, it never works. It never fucking works. Num children here. Movement. This thing is pissed at 1e4 because this thing is a pointer. Okay. What's he pissed about now? And F32. Oh, yeah. God, okay. Num siblings will do... We'll just do it like this. This needs to be a vector 2, so we'll do float from int on both of these. We'll do it like this. Boom, boom. Okay. That'll work. That'll do. That'll do, pig, that will do. Have you guys seen Babe, Pig in the City? I think he says that'll do, pig, that'll do a few times in that show. Let's see. That'll do, pig, that'll do. Yeah, Babe, Pig in the City. 1998. They just film a pig. Oh, I'm gonna get fucking demonetized if I play that whole clip. But he says that'll do, pig. It's very exciting. Still, something over here is not being pulled with everyone else. So app widget here, we definitely have like try set input state. We have input state handling on the right side. Update also on the right side. So are all these things like really close to each other? What's it like 0.2, 0.3? Why don't I see that? Oh, because we only have to, we should only be logging positions that are relevant. If node referenced by items len is greater than 0, that's the only time we want to print their positions. Because we should be seeing everything converge towards 2 points. I'm trying to understand why they're not. Yeah, okay, so now everything is fucking moving. That's kind of interesting that UI position has nan nan. And then it looks like there are still 2 distinct points. And it's probably because this thing, try set input state, is referenced by set input state. But set input state is not referenced by anyone. So that like pruning of the graph is not doing the right thing. That's interesting. So our pruning actually has to be like, we need to do something more intelligent. Maybe we don't even fully need to prune. Like the problem here is that we are tracking, the problem is that our reference tree is not complete. I'm pretty sure that's the problem. So we have this like, this app widget goes through this like widget vtable. We don't really consider this widget vtable like a thing that gets leaked externally, right? So what happens is like the way this app widget works is we like construct this widget type, boom, right? These functions all get used as like function pointers in here, but these don't leave app widget in any way, right? So what happens is like this set input state is not called by anyone, but set input state calls try set input state. Try set input state is going like, oh yeah, I'm referenced, so like I'm part of the graph, which is fucking stupid. Which is stupid. I guess it's reasonable to just have 2 graphs for now. Maybe we don't even try to like... Then also, like, we don't want to prune on if he's not referenced by anything, because like main is not referenced by anyone, but we want main on the graph. Main's a very important piece of the graph, right? So we almost want like who do I reference as well as who am I referenced by? And if both of those are 0, then I get fuck off. But like that won't happen either because all code in the code base is like relevant. Otherwise it wouldn't be there. Otherwise, it wouldn't be there. So we like this. This is stupid. This is stupid. But then we're just gonna go back to the point where it's like, okay, we're gonna go back to doing this. But I feel like we're just gonna go back to the way where it's like we've just got everything kind of sitting around. Like all of this stuff now is just floating around again. Maybe all nodes are rooted by a project node. And that project node like stays centered or something. Doesn't sound crazy. Does not sound crazy. I'd be interested to know like which things are not moving. Right? So we have like app widget D in it, app widget render, app widget get size. These are definitely problematic. But like these should be sticking to their parent. Why are they not sticking to app widget? That's like a thing that we are trying to accomplish and it's like not happening. Unless I just fucked up what I was deleting here. Right, on this step, we're supposed to pull our shit towards our parent. Let's just like fucking like calc pull. Can we maybe pass in a like let's not do this point times 0.25. Let's see if that changes anything. Probably shouldn't, because that just accelerates everything evenly. Why is this not triggering? Like, here, this app widget get size is literally not moving. But app widget's way over the fuck over here. So, like, why? Why? Because so we won't have a parent. We move the parent towards us a little bit. And then we move, or in the direction that we were pulled. Then we're supposed to move ourselves back. Can we maybe do like parent pull is this? Can we just parent pull is this much? Any, I guess. I don't know, man. And then let's do like only do this if node.name starts with app widget. Starts with, if this thing starts with app widget. I just want to see like, I feel like this should be getting pulled, and if it's not, then we have like a fucking problem. Parent. Interesting. So this is just not happening for app widget. Why the fuck not? Why the fuck not? Can we look at the DB here? Oh, that's not good. So there's just it's just, the data's just bugged. Data's bugged. So why? Why is that happening? We are supposed to when we build the tree, we make our parent name is, oh, are we just, our parent resolution is just fucking broken? This should be -1 here. We should be, yeah, can we print here, std debug print, parent of this is this. I think that this was just a mistake before we parented it to himself by like a dumbass. I think that was just a stupid little oopsies. There we go. This looks better, so we just have to wait for him to regenerate the database. It'll take a minute. It'll take a minute, but it'll be worth it. It'll be worth it, because the graph will work much more betterer. Much more betterer, as you say. And then the rest of these say, like, parent of these is nothing, which is pretty reasonable. Okay. Oh, that's so much better. That is so much better. Okay, this is what I want to see. I want to see everyone fucking get pulled into the same fucking spot. Can we also kind of like trend things towards the center? Okay, I guess. Yeah, let's trend things towards the center. I think that makes sense. I guess if we do that though, it'll just end up with everything at 0, 0. Maybe we need to start calculating our like pushing force. Our pushing force. So things that are close by to each other need to push each other away. So for now, I'm just going to do it the n squared way. I think what I eventually want to do is like, my thought here was that I'll have some sort of like low resolution map. And for each point in this thing, we could like kind of like draw some rings where like as we get farther and farther out from this thing, the pushing force from that thing gets like lower and lower. And then we could like basically update this map for every point in here and then query this map for every point. But for now, I'm just going to say for every node, for this shit, to this little double nested loop. And what do we actually care about here? Probably not the nodes themselves. But we want to like push everything away. Now this pushing force needs to get very strong as things are close together. We might need to do a different formula than calc pull. I'm not really sure yet. We'll have to think about it. But it's not really related to this. I guess we need to make sure that we have like their index. Right, so this is I, this is J. So we should only ever see each pair of points once here, right? If we start this thing, here, we'll do this. Movements len. This is I. If we go from I to movements len here, then we should only see each pair of positions one time. And if we go from I plus 1, we don't have to worry about running into each other. Which means that we do it this way. That seems reasonable. I'm pretty sure that's right. Then we just go like I don't know. I guess we'll see what happens if we just kind of treat them like the same. I pause, or A pause is this. B pause is this. Like, if we just go like 1 over calc pull? Maybe? I don't know. I don't know. B pause minus A pause? Seems reasonable, right? So as things get close, as they get closer and closer and closer, they start to have like almost infinite pushing power. But then I think this might need to be -1. Because our maximum value is 1. So this thing needs to end up having 0 push power if they're far away. Yeah. Yep. Okay. So then let's just go like, this is B relative to A. So this is like, how much am I pushing B from A is this? Half. So then we want like the B movement. To be like, we probably want to half this shit. This 1 over isn't gonna work. Fuck. So we want like, we need to be vec2s for everything to work out. And then the half push is like push over vec2 2 2. Okay. So movements J plus equals half push, and then movements I is plus equal to like negative half push. I don't know. That seems kind of reasonable. Okay, everything's nan. That kind of makes sense. Why is that? Because the pull is 0 if they're on top of each other. So, push is not equal to stood math nan f32. Can you do, does nan equal nan? I think you have to do stood math is nan. Yes. So can we just like assert this for a second? I want to see what happens. Return x not equals to x. Fuck. I think we have to push 0. Okay, so this does get hit, and we can kind of see why. I guess maybe logging is easier here. Okay, can we just like stood debug print A any B any and pull any. Like what the fuck are we doing? So this needs to be A pause, B pause, and pull. Let's just kind of see what is going on. No GDB, fuck GDB. Let's just let it crash. Let him die, you know? Okay, so what's happening here? We have A is this, B is infinity. B is ending up at infinity. Probably because this will eventually, going 1 over will eventually end up at infinity. Right, so maybe we will do a different calc push. And we need, what do we want here? We want something that gets very large, but not infinite as we get to 0. Can we just clamp instead? Does that make sense? We could get something that approaches 1 as we hit 0. Maybe that's reasonable. So, like, why is this? What's 1 plus x? wait, hold on. Of course 1 plus x is stupid. 1 over x. This thing gets very, this is like actually very close to what we want. Can we just do like x minus 1? X plus 1, I mean? Hello? 1 over x plus 1? Why did it do that? Okay. That seems reasonable. Which... So this is like 1. Isn't that what we're doing here? Oh, we did x over x plus 1 instead of 1 over x plus 1. I guess is kind of what we did here. And then we want to multiply this by some maximum amount, which is just going to be 1 for now, I guess. I don't know. I don't know, man. We just need something. Seems reasonable. Unreachable. So why? We got a nan here still? Where is this nan coming from? Can we... Oh, we did just lose our logs here, huh? Okay, so here we got these things are basically on fucking top of each other. A and B are like literally the same. So why is that nanning? Because the length is fine. Probably normalize is not. So here we need to check if length is 0. What do we do? How do we normalize a vector if length is 0? We can't. So we just need to pick a direction here. If dis is less than like some number, I guess it just has to equal 0 here. Dir is equal to, we just like push it to the right or something. Maybe we just push it diagonally upright. Sure. She seems reasonable to me. Okay. And then B, this probably has to be done here as well. Probably. We are still getting to nan, which isn't good. But B is kind of input as nan already. So who is causing that? Who is causing that? So here we have, I guess 1 plus dist should always be greater than 0. So that's fine. I mean, this dir thing could still, it could be that like this has to be if dist is less than epsilon. Could be. Can we see any like evidence of B just like this thing getting out of fucking hand? This is kind of like at 2 point. It's kind of like towards the top. Like, are there any numbers here that look like just like uber fucked? It's kind of hard to tell. Also, like a lot of numbers. Why are there so many numbers? Hold on. Is my... I feel like something's wrong in like my backward search. Like we shouldn't be seeing... Oh, we do. Has pause here. Parent pull. Okay, can we look up parent pull? So do any of these... Yeah, some of these numbers are fucking huge. Some of these numbers are fucking... Oh, they're all fucking gigantic. Which means that the push strength is just like way too fucking strong. You know? Just way too strong. Why are they all trending over there? Can we go even, like, higher? That feels better, except I think that things are getting like pushed. Dist should always be positive. Okay. Dir is fine. Push magnitude. If dist is positive, this will always be over here somewhere. Okay. Why do we calc pole, parent pole? We are trying to keep things like close to their parents, I guess. I guess we also want to keep things like close to 0. So I guess we kind of want to like take the average position here. Yeah. And then move everything so that the average position is 0. That might help us. I don't know. Math vec 2. Sure, I don't know. Okay, so for each of these things, we just go average pods divide equal by the number of things. Int float from int of the number of positions. Okay. And then we kind of just move these things over by that much. Keep things centered. Then we won't see things like fucking zip over the edge. That's not good. Why does that not fix it? Why does that not fix it? I would have thought it did. I would have thought. Interesting. Interesting. Average position is this. I mean, we're probably also like hitting like floating point imprecision every once in a while as well. Yeah, these numbers are like fucking crazy. So it's probably that things are getting pushed really far, like away from each other. I want to like take our calc push again and like can we bias it more towards smaller numbers by doing 2 plus distance or something? One over x plus 2, like that gets, oh fuck. Yeah, all these gets like gets pushed smaller. But then even then, like what if we just don't do this calc push? I feel like everything should naturally end up in the center. So we might just be making a mistake in here somehow. Let's just not do this section. I'm expecting everything to like converge on the center, but that's not even happening. So we're nanning even without pushing. Why? Why? You know? So without this like position adjustment, it's fine. It's probably that this average position thing, as we add up all the positions, is like getting fucked. Or this minus equal is wrong, but that doesn't seem right either. So we loop over all the positions, we add them up, We divided by how many there are. Let's do a... Can we just, like, panic here? I just want to see, like, one time. So our average position here is, like, pretty reasonable, probably. Can we actually log this after we log all the positions? Okay. I really don't understand the problem, to be honest. I mean, it must be like floating, like math imprecision, but yeah, can we do like if we do two F64s instead, does that change anything? I don't know, man. Uh, floatcast, I guess. Does that change anything? No, that still immediately like explodes. I don't think this is supposed to be a plus. I'm pretty sure plus makes everything worse. Dude, I feel so stupid. If pause 0 is nan, can we just like assert that it's not nan again here as well? Like, what am I missing? What am I missing? Average pause is nan in this case. Because these numbers are just getting like off the fucking chain. Look at these things, they're massive. Are we considering things that aren't part of the graph in some way? No, I don't think so. I think everything is moving every frame. Fire up the debugger, set a breakpoint, and step frame by frame to get a feel for the dynamics. That's not crazy. Yeah, that's a pretty good idea. That's a pretty good idea. Graph step. B. Oh, fuck. It's not a bad idea. Okay, can we keep this on top? Fuck. Oh, I forgot that fucking GLFW does that fucking bullshit. Where like, yeah, they're just like fucking gone. And it's because of that average position thing. Oh yeah, here we have average position of 5. How is that possible? Average position of 5. What in the fuck? Oh, because everything's on one side. No, that shouldn't make a difference. That shouldn't make a difference. I want to log all the positions again. I do still think we should breakpoint there so that we like limit how fucking far down this road we get. Okay. So average position here, mega big. But none of these guys feel like they're very far away. Oh, log error here is like mega far. Oh. No, I don't understand. I don't understand why log error is getting pushed so far away. He's immediately like getting thrown out there. Maybe he's getting pushed by literally everyone. But we are not pushing. There's literally no pushing happening. So how can he get farther away? What is causing him to go? What was the condition on the up and to the right thing? Oh, that's a good point. Is log error up and to the right really far? No. The up and to the right thing was if our distance between elements is very small and it just sets the direction. And this thing is multiplied by the magnitude. I guess here, this should return 0 actually. If they're fucking touching, no pull allowed. I don't think that's it, but it is something to be concerned about. You're right. But yeah, it doesn't seem to be it. Is it like, how is log error going into the middle of fucking nowhere? Is it because of this like Okay, what happens if we don't do this average position shit? Right, because that seems to be causing the instability. Is log error still fucked? Oh, interesting. Actually, a lot of these guys are going out over like the fucking middle of nowhere. Completely unrelated to that. It's just that the average position wasn't pulling, like all of these guys are like off the screen and we just didn't fucking notice before. So how is that happening? That's the question. That's the question. So let's take out the parent stuff, right? Take out the tying to our parents. All of that stuff is still getting fucked up. So we've kind of narrowed it down to these like reference issues. Okay. So if movement 0, we're gonna assert here that movement 0 is not nan. Is nan movement 0. Let's just see what happens there. Okay, good. That crashes. That's good for us. That's good for us. It means we can start debugging. Okay. Okay, makes sense. Makes sense. And so can we look at like what we called here? Holy fuck. total guess, but are references duplicated? If so, maybe store a list of them, or maybe store a set of them instead of a list. But I wanted that. But you are right that what will happen here is we will pull way past ourselves. You're right. So we have like main sitting here and log error sitting here, and we're like, the maximum pull is this distance, right? But then we're going like, yo, I'm gonna fucking, I reference you like 10 times, right? So what can happen is we can go like way the fuck past. And so I guess we kind of have to scale the pull by like the maximum number of references, right? So we say like this guy references me 10 times. That means all of you guys pull me fucking less than that. Does that seem reasonable? So we go like node counts is gonna be like I guess we'll say like max references. And he like looks at like reference list. And we'll be like, I guess maybe we need an allocator here as well. And I guess we like stood auto hash map from db node id to u32. I guess. We'll be like for reference list reference counts at ref is going to be something. Surely this can fail. Yeah. Okay. So if we did not find existing, value is equal to 0, then we say value plus equals 1, right? And then we say var max is equal to 0 for reference list. Nope, reference counts iterator for while we can iterate. We look at like max is equal to the max of key v value pointer and max. Return max. Okay, that seems reasonable. Then we say like each of these distances is going to be like max references given our allocator and node reference by. I don't fucking know, man. This probably doesn't have to be calculated every frame, but like, you know, whatever, fuck it for now. And we actually want this to be like disk scale is a vec2 of this thing just duplicated, I guess. So now all of these are divided by the distance scale. I think. Node reference by, I think it's items here actually. Forgot to save. Get or put, he's mad, expected type F32, found U32, so this is float from int. Okay. If this works, you might store them as a map node ID to count. Yeah, it seems reasonable. Seems reasonable. I'm sure that like whatever we're doing is fucking stupid. Like I'm not worried about there's a lot of dumb going on right now. Expected type this, found that. Gop equals try this, which means this has to be failable, which means this has to be try. Okay. Okay. Still no dice, huh? What are we looking at again? Lists, P, other pause, P pause. Yeah, pause is still fucked. We are probably like... This is UI action. Interesting. I thought that would do it, to be honest. Because again, the only thing things can do is pull each other. So, like, if we have the maximum value of this thing is distance between elements, and we're saying we're not like pulling the wrong way, right? No, because like the vast majority of these guys work okay. It's just someone is just like off in the fucking nether. It's still the same guys. Which means that this distance scale thing is not working. But I don't understand why, because calc polls max value should be 1. But we're clearly not seeing... Here's what's bothering me, is that this should never be greater than 1. This should never be greater than distance scale. Right? But this should never be greater than 1. So if it is, we have a fucking problem. It means that we're doing something fucking stupid. So std debug assert that poll 0 is less than 1 or equals 1. And if it's not, then we should look at why. Okay, so we're immediately fucking failing that. Okay. Numerical instability question mark? Oh, oops. It should be less than the oops, sorry. This should be less than the distance between other pause and pause. Math length of other pause minus pause. Okay. Of course. Some of these things start really far away from each other. Okay, so why is this? Now we're failing this, and it's because what? Because this pull becomes nan. So he's never larger than the distance. It's just the distance is getting insane. The distance is getting absurd. But how? If things are only ever getting closer to each other, how are we ever getting farther from each other? It feels like it should be so simple. We might be pulling past each other. It's also kind of weird that we're not pulling bidirectionally. That's kind of weird, but I don't think that should matter here. I do not think that should matter. Can we fucking log all of our positions again? We are logging all our positions. So when we run this... Oh, okay. Can we just log the position of like... of log error only? Because we know that one's going out into the fucking middle of nowhere. If distance is negative, doesn't it cause addition? I'll double check. I thought that I accounted for that, but I might have fucked that up. Very possible. Very possible. Okay. Why is this still printing everything else? I only want it to print the one. Is it because we're printing twice, like dumbasses? Let's try that again. Okay, here. So we are starting at boom, 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 boom. So we're like kind of like oscillating and getting bigger and bigger and bigger and bigger and bigger. Oscillating and getting bigger and bigger and bigger. So you're saying if distance is negative, distance can't be negative though. Distance can't be negative because length is the square root of square. So that shouldn't happen. I guess what's interesting here is that this whole time, the pole is never larger than the distance, right? So we're getting to the point where we're getting farther and farther and farther away. We're only pulling less than the distance to our reference item. Oh, wait. Didn't we want to do this divide by disk scale mag? Did we lose that somewhere? Oh, no, we're doing here. I mean, does this kind of just fix itself? What if we just clamp our positions? Like, as a hack for now? Can we clamp it to, like, -1 and 1? Like, obviously that's not great. Like, what's going on with these guys where they're just getting, like, stuck in the corners? I don't know. But let's try bringing back some of our other trickies now and see if that helps anything. Okay. That's fun. So some things are getting just like blown the fuck up. Some things are getting blown the fuck up. We probably need to do that same max reference scaling thing for other places. So I forget what these are all for. What is this section? This is we pull towards our parent. Okay, which is already scaled. If we leave pull towards parent in but not the push stuff, how does that look? Does that look okay? Why are some of these brown? What's going on there? What are these? Okay. Sorry, run it again. Run it again. So, the fact that they're flickering and some of them are brown makes me feel like things are flickering in and out of existence, right? And I think that we are seeing that because log error here is like just going fucking crazy here. And that's probably related to the same problem that we've had this whole time, right? It's that like he's getting pushed by so many people. So it might be interesting to log, in the case of log error, who references him and their positions. That's probably going to be interesting in some way. If we are looking at log error, we must be doing something silly. So let's print out referenced by, and let's just log their position, I guess. S with pause this. So this is referenced by like ref. So we need his name. So this is self nodes at ref value. Okay. So this is now ref node name here, and then we should be able to do like ref pause is self positions ref value. Okay. So he's referenced by this guy over here. Right, so he's like, I want to go towards main. But then there's also some stuff over here. What is my like movement? Like, is this just like fucking like dumb, stupid dumb? Movement. Like it. Oops. I should probably new line there, huh? Huh? Probably should. Probably should. Okay, so here, I'm like, my movement is negative 0.27, 0.23. Okay? I am here. And main is over here. So it makes sense for me to movement here is this, then here's this. So he's alternating, which is weird. Alternating by very similar amounts, to be honest. Also interesting. It would be interesting to maybe see who is adding up to that, but let's see if we can guess here. So he's referenced by all of these guys who are in this cluster. I wonder if dividing by max. Are we supposed to not divide by max, but by number of references? Seems kind of possible. Let's see what happens if we do that. That seems a lot more reasonable. That seems a lot more reasonable. So before we were saying main references us 10 times, this guy references us twice, let's divide by 10. And now we're saying main references us 10 times, this guy references by 2 times, let's divide by 12. And for some reason that has like a way different effect. Okay. Okay. I'll have to think about that a little more. But sure. And I think we probably need to give like the same treatment here on push. Where push needs to be limited, he's going to be pushed by everyone. We'll just see what happens. Let's just see what happens. Okay. I don't really understand. Did we lose the averaging shit? We did. Okay, let's bring this averaging shit back as well. Does everything kind of just work better now? I don't know why this averaging stuff. Oh, because I'm not actually doing it. Sure. Okay. That's something. Bitrate? Oh, is it like just because of the fucking scrolling text? Okay, let's get some of that out of the way. bum, 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 bum. I guess we just comment out the whole if statement. Okay. We need to probably tune this a little bit to gain like stability. But this is interesting. That's like a constant shape. They're twisting because of something. But it would be interesting to see who these chunks are. Can we do something that's like colors the nodes differently depending on their parent? That might be kind of interesting. Can we take a look at that? Let's say, let's, let's just do it as a uniform. Okay. So here we'll have color XYZ. And then we'll just do a second draw call for the pieces that are on top. It's easier that way. Not really great, but good enough. So we say first do everyone with a... How do these uniforms work? Okay, can we just see what happens if I do like... Sorry. If we just try to make them blue right now, I just want to see what happens. It's float 3. Like this. Okay. I just want to see what happens if we try to make them blue. Just for now. Yeah, okay, so that makes them blue. That's good. And so now can we just color them according to if they start with app widget? Let's just start there. So we'll go like, we render this once, white. Then we render it again, but we say app widget positions is equal to an array list of positions. Defer these, get the fuck out of here. Go bye-bye, get destroyed. Then we say for graph.nodes, graph.positions, node pause, if node name starts with app widget, we will push this app widget positions append pause. Then we run this again with the app widget positions and just with a different color. So hopefully this will show us interesting. So that's either a lot of dots all close together, or it's broken. App widget. Oh yeah, starts with this really good point. Thank you. Good point. Y'all are smart. Okay, so that's kind of interesting. Can we say we'll do this again? But I want to show the root of app widget as a different color. So this is literally just equal. And we'll do this one in green or something. So probably what's happening here is main. Can we find main as well? Let's just see if we can find main here. So main is here. He is using app widget a lot. Now someone else, why aren't these guys all getting like yoinkied into here? Them being all grouped together at least is a good sign, right? But maybe they can't get past this. Yeah, I think it's depends on the seed, I bet. I bet you if we do a different seed here, we'll just get something completely different. So like depending on the initial layout. Interesting. It does actually look kind of similar, huh? But I wonder why. So I guess probably main is referencing app a lot and pulling it really close, or app widget a lot. Pulling it really close. No. Yes? Hold on. Can we look at the fucking code? Can we look at the fucking code that we are trying to graph? App widget. Who the fuck uses this thing? It's literally used in one place. Main? Shouldn't he be getting yoinkied towards all of his children? Like, shouldn't they all be applying, like, come to me, sir? When we do, like, the parent thing? Like, what's going on here? What's going on here? They should all be going, like, I need to get over there. Is the parent pull in the wrong direction or something? Parent pull is calculate the pull towards parent pause. Then I up this thing. Sure. What if we just do like something stupid? Like say like I really want you to be close to the parent. Does that work the way I expect? Oh god. Oh god. Smaller, 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 smaller. I actually think it makes more sense to multiply the distance here by a lot. Say we're way farther than we are, because this thing caps out at the... Even that's not working correctly. Parent pull here is like 9, which doesn't make sense. Parent pull should never... Like, this value is supposed to be stuck under under 1.0. Is it not? Is it not? But we're getting to like 8. Or like even like 10. So that means that this calc pull just must not do what I think. Oh, because we're multiplied by the distance. God fucking damn it, dude. God damn it. What if we just don't do that? Okay. Okay. Hold on. Let's go back here. Okay, everyone's really stuck together now, which makes sense because these things used to be multiplied by their distance. Right? They used to say the maximum you can move is right next as the distance between us. Now you can move as much as you want, up to a whole screen, which is no good. No good at all. I wonder if we should do like max dist here. Okay. We could do something like this. And then here, when we are pulling by our references, we just use other like math length other pause minus pause. We keep that the same, but when we pull towards our parent, we multiply the input by a lot, but still use parent pause minus pause length as the maximum pull. So we say pull by more, but still don't exceed this crazy number. Whoa, this is also fucking stupid. I don't know what, I had a double calc pull there, which somebody actually pointed out a while ago. But I didn't understand that that's what they were pointing out. I just didn't understand. Okay. Oh, that's a lot better. That's a lot better. So now we're seeing what color was parent pull, or what color was app widget? App widget is main red, app widget green, app widget children blue. Okay. So now we are seeing some reasonable behavior where all the blue dots are close to each other. Now let's kind of reduce the amount that they're going to be tied to their parent. Right? So let's go like 5, 5 maybe here. Okay. And then let's kind of like increase the pushing force of everything to get everything like closer. So I think we want to apply the same. I guess here we just reduce this number. Okay. Okay. Can we reduce this? Or actually, I wanted to, yeah, reduce it or increase this even more. So let's try to pick some more reasonable numbers again. Holy shit. Ow, ow, ow. Oh, it's making me sick. But, okay, let's try to get some more coloring going on. Let's see if we can like, I want to look at like UI action as well. So paste, UI action. We'll make this guy cyan. And we'll do UI action here again, but make him some other color to show the center. Jesus Christ. Oh. Oh, okay, so everything is like, there needs to be some sort of like damping force, probably. Like over time, we need to get smaller. But like, that's pretty interesting. Oh god, we lose the fucking, it grays himself out. God damn it. Can we just do like for 0, var I equals like 0, and then defer if I is less than like 10,000, we do this. I plus equals 1. Then it should eventually like stop and we can take a look at it. Too many. How fucking many iterations do we need? 1,000? I thought this runs like 144 hertz. 10,000 didn't seem like that much. I guess even like at 144 hertz, 1,000 is okay. Whatever. So this is interesting to some extent, right? This is main over here. This is all of the app widget stuff. This is all the UI action stuff. So we definitely are seeing some groupings, which is pretty cool. Pretty cool. I mean, obviously, some changes need to be made. It would be probably nicer if we drew lines between stuff that would help us like gain more intuition. But the idea now is starting to seem kind of sane, right? The idea of being like, we can kind of put points around and have things push and pull. I think the push and pull needs to be tuned a lot, and I don't really like there's something like very like liney about these things, right? So probably we need to adjust hand wavy something. I guess maybe it kind of makes sense that like things like main probably has a lot of control, right? Main is probably pushing and pulling everybody a lot. And so it might make sense that things like line up kind of perpendicular to main, which you're kind of seeing here, right? Like these guys are all pointing towards main, these are pointing towards main, these are pointing towards main. But yeah, I don't know. I don't know. Probably next steps are we probably have to like find a better way of like inspecting this stuff at runtime, right? Maybe like we hover over stuff and get some information about it or something. But I think this is a good initial attempt. A good initial attempt. We've gained a lot of info at the very least. It doesn't look great, but we've gained info. So we'll call ourselves happy with that. It is 4:30, so it is time to stop. Thank you for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 4:30 now, so you should expect us to see us online between 4 hours ago and now on a typical day. We are working on this code mapping idea. We will probably stay at this for at the very least, a few more days, probably on the scale of like a week or more. There's a lot more work to do here for sure. Yeah, we'll be back tomorrow. If you're watching live and you're like, wait, I won't be online tomorrow at the right amount of time, you can check out the YouTube. The YouTube has videos organized in a playlist. We're working on building a map of our code. There's also a GitHub link in the Twitch description where the code map repo will have this code eventually cleaned up and put up there. If you watch the VODs, you might say 12:30 to 4. These VODs are only 2 hours long. That would be because the 12:32 segment is kind of like less of a new feature, titleable, thumbnailable thing, and more of a kind of like do what stuff that's got to get done, but it doesn't really fit into a YouTube title. So today we were working on trying to get our code walking for this project to process multiple files. This is all right now one file main. Eventually we're gonna have to get the whole project, but we'll figure that out. So if you want access to those VODs, you have to hit the join button on YouTube or on Patreon or sub on Twitch, and the VODs will be in the appropriate places for that segment of the stream. But if you don't, you won't miss anything too important. We try to keep all of the like typical important feature development on the mainstream. So I think that is all. YouTube, peace out. Twitch, let's find someone to raid.